Awesome. Okay, howdy everybody. We are Team 7. I'm Cameron Berger. I have Jacob Blank, Tristan Burrick, and Ian McDonald with me today, and we are going to present you all our risk analysis and our implementation plan. So on the agenda, what we're going to show you guys today, we're going to start by just briefly revisiting our project description and those problem statement requirements, just to give you guys a refresher of what we're working on this semester and what is expected from us for our client. Then we're going to move to our project solution. We're going to discuss specifically what that's going to look like, as well as present some AutoCAD schematics to show you guys really how that's going to get broken down. And then from there, we're going to go into some associated risks and mitigation tactics that our team is going to present to our client. And then we're going to wrap up with our implementation plan, how we're going to suggest that our client moves forward with installing this recommended solution, address, how we're going to move forward from here, our next steps towards this process, and then finish up with taking any questions from you guys. So we are tackling the dust collection system at United Ag. They are a grain elevator co-op in El Campo, Texas. So specifically, they asked us to focus on their dust unloading pit, and this is the area on their site where the trucks are pulling up and they're dumping their grain into their pit to be moved throughout the site. So this is specifically where Stephen Craig, our communication person at United Ag, asked us to focus on. And so specifically here, there's no immediate monetary penalty. There's no issues with them breaking regulation currently or any red flags with their current system. He just specifically asked us to take this on to help improve the work environment for their employees that are currently working in that dust pit area. These are the people that are, unloading the hopper, that are moving around, and they're just being exposed to some of that grain dust particle emissions. So we're simply just trying to make that an even more safer environment for them. So moving forward, Jacob's going to go ahead and walk you guys through our project solution, as well as some of those schematics that I discussed.
Yeah, so before we address the risks that come along with our proposed solution, it's important that everybody has a good understanding as to what our team's recommended solution is. So I'm just kind of going to briefly discuss that and how it all works. So our team's recommended solution is to add a hopper sleeve cover during the grain unloading process. So the trucks carrying grain will first enter the unloading pit. Once inside, the truck buster employee, that's the person who's actually going to be physically unloading the grain. They'll attach the sleeve cover to the truck's unloading hopper, seen there in figure 1. So the sleeve is going to be attached to the truck hopper right where the grain is being dumped out of. You can really get a good kind of visual of this in that figure 1 right there. The sleeve will be positioned flush with the truck's unloading hopper, and the grates covering the unloading hopper below the truck. So the hopper sleeve cover itself will be constructed out of 16 gauge aluminum metal that will wrap around the spout of the truck's hopper and securely close through the use of some tension latches. So this will really be able to seal the grain and dust inside the sleeve while it falls into the remainder of the unloading pit system in efforts to help solve United Ag's dust emission problem. So let's kind of take a look at some of those design schematics. So a side view of the hopper sleeve can be seen here in figure 2. All the dimensions seen in this schematic are measured in feet. So the hopper sleeve itself has a length of 4 feet, a width of 3 feet, and a height of 3 feet in order to securely fit around the industry's average size truck unloading hopper. The hopper sleeve cover consists of the hopper sleeve itself, a lock plate that latches across the hopper sleeve in order to securely open and close the equipment. So as you can see, there's 2 hinges labeled in figure 2. The bigger hinge on the left there, it's there to allow the hopper sleeve to open and close. All the smaller hinge is attached to the plate cover piece in order to allow that plate cover to open and close. There's also 2 lock plate latches that are shown in the figure 2. They're there in order to keep the whole piece of equipment closed and secured during operational use. So kind of the last main thing pertaining to this equipment is the vertical cut. So there's a vertical cut in the hopper sleeve that you can see just behind the plate cover there. It's that white vertical line in figure 2. So that cut's there. And it has to be made in order to allow the hopper sleeve to open and close. So all in all, the hopper sleeve will be able to open and close due to that vertical cut I just talked about, along with the use of its hinge. Once the hopper sleeve is attached, positioned, and closed, that lock plate can then be positioned in the closed position. And then finally, the lock plate is kept closed by fastening the lock plate latches. So let's kind of move on to figure 3. Figure 3, you can see a top view of the hopper sleeve along with its hinges and plate cover. So you can see there the main big hinge, and then also the smaller hinge for the plate cover, and the plate cover itself kind of there at the bottom. And then let's move on to figure 4. So figure 4 shows the hopper sleeve outlined in red when it's actually being used within the field. So as you can see there, the grain dumps out from the truck hopper through the hopper sleeve itself and then flows into the unloading pit below. So now let's address some of the risks that come along with implementing a piece of equipment like this. So the first risk I'll be addressing is the risk of improperly attaching the hopper sleeve cover to the truck. So we know, human error is inevitable. This is something that we know is going to happen. It's likely that the hopper sleeve cover will at some point be improperly attached during its life of use, whether that be through employee carelessness, working too fast, an accident. There could be multiple reasons as to why this would happen. However, in order to help mitigate this risk, our team has made it clear that United Ag should take sufficient time to train their employees on how to use this piece of equipment. It's a quite simple piece of equipment, so we've only advised that they train their employees for at least an hour and really be sure to practice attaching and detaching the hopper sleeve. We also recommend that United Ag implement visual inspection checks to help reduce improper attachment. There's 2 employees working within the grain elevator unloading pits. The truck buster and the pit operator. Those are the 2 employees that'll be working. So our team suggests that United Ag require the pit operator to always visually check if the hopper sleeve cover is attached correctly to the truck hopper before the truck buster begins to unload the grain. This will really, really help to ensure that no mistakes were made during the attachment process, and the piece of equipment is always securely attached before it's operational and used. So Tristan will now be addressing the remaining risks and kind of explaining the steps our team recommends United Ag take in order to prevent those.
Thanks, Jacob. So bottlenecking is more of a risk that can result from improper attachment, human error, but it still could happen due to the structural integrity of the actual sleeve. But the potential clogging is evident. It would most likely be from improper attachment, but what it could happen would be the sides of the tank kind of fall in and catch grain, and the weight of the grain just push it down, creating a smaller area and a bottleneck type deal. But we did try to mitigate these risks in the design of this, and we made it slightly larger than the size of the grain hopper. In order if it was too small, if it was smaller, it wouldn't bottleneck. And added features can be put into place. This would be something that United Ag, they use it for a while and they come back to us and say, hey, the sides of this weren't stronger, or we need to add some structural supports to this to beef it up a little bit to make sure it doesn't conclave in and create a bottleneck that would clog grain and take more time. So durability and longevity, wear and tear is inevitable. This is aluminum, so we're not really going to be worried about rust or anything like that. But it's going to be a smaller gauge type of metal, so it's not going to be able to take a 100,000-pound truck running over it and be able to work properly after that. This also goes to the extensive training. Will assist in making sure that it lasts as long as it can. Making sure that it's put on correctly, making sure that it's taken off before the truck driver drives off, making sure that it's stored correctly, making sure that it's latched completely before you start dumping grain into it, because that can pop one of the latches, or that could even bend the actual sleeve. We do recommend United Ag allocates funds for regular replacements and have replacements readily available. This would be something that we're unsure of right now. This would be something that, we don't know if it might last a week. We don't know if it might last a year. It would just be something we have to work through as the season progresses and as it's used extensively, which it will be. And an injury can always happen. whether that's human error, whether that's just something unpredicted. But training will help. Training will definitely help with this. We ask that they do a minimum of 1 hour. Um, any more than that is great. And as much training on injury prevention is always better. A big deal with this is there are a lot of moving parts with this. Somebody's underneath the truck installing the sleeve, so the driver is always going to have to be in communication to make sure that he knows where that person is before he moves, before he does anything. That's where verbal and hand signals come into play. Since there are two employees working the grain pit, one employee while they're installing the system, the other employee needs to be either verbally communicating or giving hand signals to the truck driver, making sure that that person is clear from underneath the truck before moving. And there are definitely pinch points within the actual sleeve. There's two hinges, and where the sleeve connects to the grain hopper, somebody's finger or hand can get pinched there. So it's just going to kind of be one of those deals. Training is going to help. The more you do it, the more you get comfortable with it. So how that's going to how you can prevent that from happening. So there are learnable and random risk associated with this. Improper attachment, that goes back to training. So will bottlenecking. That just goes back to the more they use it, the more they're going to be comfortable with it, the more they're going to know how to do it. And if they make a mistake, they can learn from it. That's what the improper attachment. If they forget to close the bottom latch, they'll just have to remember to do it next time, and then that risk is no longer there. Random risk, the durability and longevity. Right now, we don't know how long these are going to last. Then that's going to be something that we're going to have to work through with the client to make sure that they have readily available extras there. So when it does go out, they can use it and they're not down on time. And an injury. Injury can almost be a learnable and random risk, such as improper attachments. You stick your finger in the latch and you latch it. You'll learn not to do that again next time. But a random risk can be just the airbags in the truck popping. I've seen that before. Airbags in the popping and hitting somebody. That's something that nobody can really predict, and it's just completely random. So it's always going to be a random injury risk. It's just important that they have a first aid station there, and then that's where training comes into play. That if somebody's hand does get pinched or a finger, that they know what to do and they have readily available supplies there. So Ian's going to go ahead and take it over with the implementation plan, and there you go, Ian.
All right, so we came up with a 7-step implementation plan that we project will take between 27 and 44 days. 27 being everything goes perfectly, but we all know Murphy's Law does not allow that, so we expect somewhere more in the middle. But the first step is finalize the design and confirm with Stephen and United Ag. During this phase, we will be presenting our current form of the hopper sleeve to Stephen, which is that metal, the sheet metal sleeve that fits around and clamps to the outlet of the grain truck with the dimensions as we showed above. And then after we present that, we're going to discuss with them to see what adjustments need to be made. And then after we finalize those adjustments, we will then start taking it to the vendors necessary to, or we will start building a budget off of that. And then step 2 is we are going to take it to the vendors, take the designs to the vendors, and see what kind of quotes we can get from them, and bring those quotes back to United Ag and discuss and determine which of those vendors will best fulfill United Ag's needs, and then go forward with that vendor. Third phase, which is potentially the longest phase, is just the production of the hopper sleeve. We have no real effect on that. That's all on the vendor and how they control that. We suspect it'll take between 5 and 15 days, but I think ideally we'll be looking more in the 10-day range. But while the hopper sleeve is being produced, we will be introducing the idea of it to the United Ag employees. We're basically going to go through and brief them on how it's going to work and the basics of why we are implementing it. Then after we do that, and after the sleeve has been fabricated, we will deliver the sleeve and then start training the United Ag management on how to implement it so they can implement it themselves, but also start training their employees to implement it. Step 6 is the initial implementation of it. This includes training all the employees to use the hopper sleeve, and we will work with them some more on how to refine its implementation, the training necessary for it, and streamlining how they use it. In this stage, we will also be working with United Ag to develop a set of standard operating procedures that includes attachment and detachment and storage, as well as preventative maintenance, and get a better idea of how long each hopper sleeve will last. And then our last step is the final testing confirmation. It's just our confirmation of making sure it works, and then continuing to refine the sleeve to see how we can improve it. Then we have a Gantt chart. This Gantt chart is the shortest possible time we've projected. We expect it to be a little longer, but if all goes well, everything goes perfectly, we're sitting at 27 days. And then going forward, we are going to be finishing up our risk analysis and implementation plan. If we need to add any more risks, or we need to add more steps or refine our steps a little better, we will continue to do that through the next week. And then we're going to start our final report, start pushing that together so that we can do that with United Ag and Stephen. Then we're also going to be making our poster for the capstone event, and then planning for our final presentation. And any questions?
Okay, let's let Team 9 ask a few questions and comments, please.
I want to say the first thing that stuck out to me was y'all's CAD drawing. I thought was incredibly easy to follow, and with it being dimensioned and easily, the way it was laid out just made it easy to follow. And with y'all's description of what was going on in the diagram, I thought that that was one of my probably favorite parts of the presentation.
When inspecting to see if the sleeves put on correctly, will they have to be trained to do that, or is that something they should already know?
We will be training them, or we will train United Ag and the management so that they can train their employees.
Okay.
What do you expect to go wrong, Ian?
I don't necessarily expect anything to go wrong. I'm expected there to be some flexibility in how long each stage will take. Not necessarily anything wrong, just things taking more time than we expect, or than we would like.
All right, that's pretty good. Thanks, Team 9, for those comments. Okay, what I'm going to do now is I'm going to assume the role of the client, and then I'll ask Dr. Castell to make her instructor comments, and then I'll come back up and make my instructor comments. Okay, so I've got my client on here. I've got my United Ag hat. I'm Stephen Craig. Okay, so it's a great presentation. I appreciate all the work you guys put into that. Go back to the. I have some questions on the drawings. Those drawings really help me to understand what's going on. But let's go to the next drawing, Figure 3. So this hinge in the upper left-hand corner, what's the diameter of that hinge? How big is it? I mean, on the drawing, it looks like it's It's pretty big.
Go back to the last slide. I have it
Yeah.
labeled. It is 6 inches.
I don't see that on there.
It's got dimensions right there. It's on the top left, 0.5.
Okay, so that's in feet. All right. So we're talking about a hinge that is 6 inches in diameter, huh? I've never seen a hinge that big. Anyway. So here's why I asked it. Go to the next slide. So it looks like, I mean, I'm talking about fitting this sleeve on a rectangular hopper, the bottom of the truck. Is that big old hinge going to be in the way?
No, sir. That's why we made it bigger. We made the actual sleeve larger than to account for space issues.
Well, I don't think y'all can see me, my mouse drawing on there. Okay, it just looks like there's going to be a gap between the wall of the sleeve and where the hopper is, and so that would allow some dust to get out, but not much. Go to your next slide. So it looks like the diameter of the hopper is, this distance right here is 4 feet, which is the long dimension of the hopper, and this is 16 gauge aluminum. Is the aluminum pretty flexible? I mean, 16 gauge is, if we're talking about something that's 4 feet by, go back to your next slide, your last slide. 4 feet by 3 feet. Do I really need a hinge, or want this, or maybe it could just be one solid rectangular piece that you can just flex? Did you consider that, or do I really need a hinge?
I mean, you could. The flex option like that, you're putting a lot of stress on the actual welded joints of it, so you're running into the possibility of breaking those welds and then having to replace it. But the hinge would just be something that wouldn't stress the corner welds of that.
Okay. Yeah, I like your risk analysis. And you know what? You got down to risk number 4, the potential for injury. Yeah, and that's a good one that is really an aspect of since this solution requires somebody to actually physically get under the truck, that presents more risk of injury, not only from the truck driving over them, but just maybe they might get trapped under there or something. So this is a big one. Why didn't you make this one number 1? I mean, I'm more concerned about this than I am about the durability of these hoppers. This would seem like this would be the number 1 risk that I'm concerned about. I'm surprised it ended up as number 4. Is that an expression of its priority or anything?
No,
they're not listed them priority.
Okay.
They're just kind of 1 through 4 risks.
Yeah, I'd probably want to maybe consider putting chocks on the truck to make sure they don't accidentally drive off while the guy's underneath. So, I mean, Tristan, I know you worked at a pit like this. Would that work for my truck buster to go in before he gets under the truck? He's got to put chocks under a wheel. Then he puts on the hopper sleeve, and then once he removes the hopper sleeve, then he can take the chocks off. Would that be something I might want to do to mitigate him getting over?
You could, but it would take so much time that it would really make the operation very inefficient, because they're just trying to get trucks in and out as quickly as they can, with some degree to injury. But that's why they just rely on making sure that the truck driver does not drive off, and that's why there's 2 people working it, so one person can signal to the driver when he's clear or not.
Okay. All right. Well, hey, good job. Thanks a lot, Dr. Costello.
Okay, here's an instructor assessment. I like this team. I like the work they do. It's very clear that we put a lot of effort and you deliver a good product, so excellent. The organization is great. The only issue we have from the presentation standpoint, I would have placed figure 4 first, because I'm not familiar with that setup. So I really had a hard time visualizing where we go. So when your figure 4 really helped me understand where would that sleep go related to the trucks. I would have put that first and then proceed with your other drawings, where you did a very good job, Jacob, explaining everything. But I would have used a pointer because you kept saying you can see the white line and all the lines are white. So I have a hard time looking at the 2D drawings in that way. So otherwise, everything was great. You know what you're doing. The risks were thought of, and you had mitigation strategies. I had a question, and again, every time you're presenting, you are leaving openings for questions. So that has to do with Edward's question, what can go wrong? Because Ian, you said something, we need to improve it, we will refine the design, and that made me question it, what can go wrong and what can be improved. So that was a good catch by Edwards, but it brings the issue that you're opening the audience for questions, right, and so forth. One last question, are you providing in your report some kind of training manual, any training instructions or on all the things that you have said today? Is that going to be part of your deliverables? But you keep saying training is important. So are you providing the client a manual or something?
That's something that we definitely could do. As of right now, I don't think that was necessarily our plan to include like an exact training manual or specifics, because it's so simple to use, and because United Ag will probably understand just based off of our implementation plans and kind of our paragraphs about how we work through it and how the whole process works.
You know, the point that you keep saying, all of you keep stressing the importance of training. So
I can add to that a little more. In step 6, part of what we have planned is to develop a set of SOPs or standard operating procedures. Those SOPs will include a training plan on how to continually train employees and a written standard for how the hopper sleeve will be employed.
Okay, great. Good answer. Yes. Very good. Excellent job. Good effort.
All right, thank you, Dr. Castell. All right, we got about 7 minutes before we do our changeover. It was a good presentation. You guys are continually improving throughout the course. It's 18 minutes, so it's a little bit on the long side. We'll talk about that in a minute. The organization of the presentation was outstanding. It was evident that you planned on who's going to say what, and the fact that you changed from Jacob to Tristan between risk 1 and 2 told me that you guys probably rehearsed it and said, okay, it looks like we need to give Jacob a little bit more and Tristan a little bit less. You know, Tristan can't do all the risks because it would be too long. So let's give Jacob some of it. So I assume that's what you did, because it was a kind of an unnatural break between risk 1 and risk 2. But that's fine. You did it to manage the time. So I can appreciate that. Your slides are good. You're using bullets instead of sentences. The font size is good. I thought your risk analysis, the risks you identified were good. I think the risk of injury, like the client pointed out, is probably your number 1 risk. You know, I don't care if these things, you know, ultimately your client isn't going to lose a lot of money if these things wear out and they have to be replaced a lot. But if somebody gets run over, that is a problem. That is a showstopper. So I'm glad you identified that risk. The only thing I would say about your risk slides is that you could probably use a little bit more organization here. And here's what I mean. You present the risk, and your bullets, injuries can always occur. Training can help. It's a little too general. Be more specific. As a matter of fact, injuries can always occur. Doesn't really say a lot. I would probably change that bullet to employee under truck. You know, is a hazard, something like that. So be more specific on what kind of injury. Are you talking about? He just stumbling over the grate as he goes in there. No, you're talking about under truck is a issue. So identify the risk, and then I would probably have a sub bullet here, mitigation. Here's how we're going to mitigate this risk, because these other bullets are not part of the risk. They're part of the mitigation training, checklists, verbal compromise. All these mitigation steps, you need to highlight that instead of just blending it all together as risk, because this is the risk, these are your mitigation steps. Every slide could have been improved. Your risk slides could have been improved by highlighting your mitigation. You did a good job identifying and describing them verbally, but one of the objectives of this class is to make sure you can do that in your presentation as well. So there's a comment for you. Those are the comments on the slides. Your drawings, yeah, you know what? You guys are one of the few teams that has drawings, so my hat's off to you. Good job. They're still a little crude, I think, but I'm not going to say anything more about that. Good job. You've done everything we've asked you to in terms of labeling them and all that. So well done there. So this presentation was a little bit long. Let me ask you some questions. What caused this presentation to go long, do you think? What could you have done to streamline it a little bit?
I think this one, out of, I guess, all four, I think we just kind of talked a little slower rather than, I think our other presentations were a little bit, I guess, quicker just in nature of our speed of talking. I think I talked a little bit slow. I think Ian talked kind of a little bit slower than normal. I think that was really it. So I guess, yeah, I don't know. I guess that could be improved through more practice or whatnot. But I think that was kind of the main thing that contributed to the length.
I think this one just had a lot of information.
That as well.
And we kind of all discussed we would rather go long and include it all than go short and not include everything.
Okay. Did y'all rehearse this presentation? I mean, it kind of looks like you did, but
yes.
Yes, sir.
Okay. Well, here are a couple of my observations on why it went long. First of all, Tristan, your discussion on the learnable and random risks, that probably, if I'm sitting there as the client, that's a really, that's probably something that you could put in your written report. Maybe didn't need to make it to the oral presentation. That was interesting, but it didn't really result in any sort of action on the part of the client. So I would have probably edited that out. It was good information, but that discussion went a little bit long. Secondly, I felt like, and Jacob, I wrote down the word fast next to you. I thought you were talking a little bit too fast, but you went for 5 minutes, so you got a lot of information out there. Ian, how do you feel like your part of the presentation went?
I think I could have gone a little smoother, but overall, not too bad at all.
I wrote down the word rough. Yeah, you could have gone a little smoother. I felt like you were rough. I felt like as the slides came up, you were kind of reaching for what you were going to say. There's a lot of uhs and but. I'm going to ask you to watch I want you to watch your part of the presentation again and do another self-critique on your presentation. I feel like you've done better than this one. As a matter of fact, even just looking at you on the Zoom, I felt like you were kind of leaning back. You weren't really engaged. So your body language was a little bit, I don't know, not so engaged. Another thing I would recommend to everybody when you do a Zoom presentation is, look around your background, sanitize your area. Political flags, not everybody's going to agree with you. So don't throw up things that, don't have things in the background that may distract people, is all I'll say there. Whether it's a political flag or maybe your dirty laundry or a towel hanging on the whatever. And I'm not just talking to you. Your implementation plan was good. The Gantt chart was probably the best part of it. Your slides with the activities, the schedule, that was almost like too much bullets. Probably could have had some more words on there. Maybe one slide per, but then again, it was already too long. So I take that back. Cameron, your part of the presentation was good, but let's go to your slides because there's a couple of errors I want to talk about. The first slide, I love the fact that you start with a project description. Modification of current dust pit. Okay, let's see. What are your first two words there?
Dust collection.
Dust collection. Does that accurately describe what you're doing?
Yeah.
I believe so. I mean, we are grabbing it out of the air as it's coming out of the hopper sleeve. I mean, it's being collected. I guess. I mean, I could be more descriptive using something like emissions collection, dust emissions collection, but.
I'm nitpicking here. Your presentation was so good that I can nitpick over words a little bit. Really, it's dust reduction. You're reducing emission. You're not really collecting it. You're not taking it out of the grain stream and collecting it and putting it somewhere else. And in air pollution lingo, that's what that means. So just a little bit of a technical correction there. That's about all I've got time for, really. Hey, good job. You guys really have responded to all of our critiques, and you're getting better each time.
Yes.
And I feel like that you've got a solution that will make your client pretty happy. So